This is the second video from chapter 34, the alternating series test. So I guess I lied in the first video when I said that that concluded the chapter 34. I wanted to break this chapter up into two sections, the alternating series test and then the error estimate for the alternating series test. That's what part 2 of this chapter is about. Now, the example that I'm going to do, example 219, is one of the problems from the textbook. This is problem 26 from page 776. So there are two things we want to do. First of all, we want to show that this series converges by the alternating series test, and then we want to get the remainder within 1/20,000th. We want to find the sum so that the remainder is within 1/20,000th of the true sum. So first of all, since one over 1 divided by n to the n is less than or equal to 1 over n, and the limit as n tends to infinity of 1 over n is 0, the limit as n tends to infinity of 1 over n to the n is also 0. Therefore, the series converges by the alternating series test. So our series converges. So this is an example like the first video on chapter 34. So now what we want to do is we want to get a sum so that s minus Sn is less than 0.00005. That is the problem given in the text. And so what the remainder estimate for the alternating series test says is that if we look at our partial sum to Sn, and we look at the difference between S and Sn, take the absolute value, that is less than or equal to the n plus 1 term of the sequence. So the Sn is the partial sum that we make from the sequence. And so here, when we look at this, what we want is we want one over 20,000 to be less than 1 divided by n plus 1 to the n plus 1. And so what we do is we start checking numbers. What happens when n is 1? What happens when n is 2? What happens when n is 3? Etc. And it turns out that 1/5 to the 5th power is equal to 0.00032, which is less than 0.00005. And so what this tells us then is that s minus s sub 4 is less than or equal to 1/5 to the 5th. This is what the remainder estimate for the alternating series test tells us. And so if we just calculate s sub 4, so we start with 1. When n is 1, we have -1 plus 1/2 squared minus 1/3 cubed plus 1/4 to the fourth, our fourth partial sum is within this distance of S sub 4. So when we look at S sub 4, we are within 1/20,000th of the true sum. This concludes the video over part 2 of chapter 34 and actually does conclude the videos of chapter 34.